Welcome to one. In this video lecture series, we will discuss about an topic is analysis of a residential heat pump. So, is heat pump is basically working in the principle of second law of thermodynamics. So, the second law of thermodynamics is Kelvin-Planck statement and a Clausius statement. This is the working graphical image of a heat pump. So in this heat pump, there is a components are compressor, evaporator, and condenser, and heat input section and heat output section. So in this heat input section, the heat will goes into the spot, and it is goes to the compressor section. It's a compressed air, and finally it is goes to the evaporate section, and its evaporate is valve will be located in here. For the evaporator valve will the additional heat it's to the condenser area. So the condenser area is in a heat output and condensing unit. So use of heat engines in heat pumps is a working of heat pump to warm up an interior space, and its pumps and refrigerators, and a heat pumps a coefficient as a performance. So introduction of this heat pump area, introduction of this part will located as in a working fluid as a gas, and electricity out in the generator, and turbine will be located in here, and it's a waste in heat evaporator and a condenser, and waste output of a heat pump and the form cooler is here. So the sudden loss is not enough of a heat is in a blowing of a cold air. So this principle of a heat pump is transfer heat by a circulating a substance called a refrigerant through a cycle of evaporation and condensation, and compressor pumps the refrigerant between two heat exchanger coils. In one coil, the refrigerant is evaporated at low pressure and absorbs heat from its surroundings. So it will be of a compressor, vapor, expansion device, and separator of liquid and waste heat. So this is the graphical images and thermal representation of the pressure and volume diagram. Though a point AB is in isentropic compression, and BC is an adiabatic compression, and CD is an isothermal expansion, and AD is an isothermal expansion of points. So the heat pump compresses the refrigerant to make it hotter on the side to be warmed, releases the pressure at the side where heat is absorbed. So and is an evaporator and a compressor of a heat exchanger valves in the evaporator unit is an outdoor unit. It's a safety valve, and the refrigerant and fluid thermodynamic cycle is an indoor box, and the plate heat exchanger, and the circulation pump is also here, and heat exchanger unit will be located is in here. So the application of during this heat pump process is in a drying process and washing process, and heating of process of water with waste heat from a refrigeration system, and pinch analysis and pasteurization, and industrial plants provide a wide variety of heat sources potential uses, and the heat pump is a prompting technique with numerous application in the industry. And these are the some multiple type questions from heat pump unit is how could we use one compressibility factor chart for all the substances is in options are 0, unity, and 0.5 and infinity. And in high pressure condition, the real gases conform more closely with van der Waals equation, ideal gas equation, as both A and B, and none of the above. So the perfect example of an ideal gas is air, water, and salt, and ice cream. So this is the lecture video about on a topic of heat pump working process in aero engineering thermodynamics part. So we know about in this video, we clearly know about the working principles of thermodynamics unit area of heat pump. Thank you.